Okay, welcome to lesson 73 of algebraic concepts, arithmetic and geometric sequences. Okay, so this is, I guess, part C. So if you look in the intro to algebra videos, algebraic concepts starts with expressions and equations. Now it starts with expressions and something else. Then it moves into equations and inequalities. Then we move into functions. And so this, and then it goes to polynomials and something else. So this will be the first in a series. I believe there are 6 or 7 videos or upcoming videos, or 5 after this, dealing with sequences. So when we think about sequences, we're talking about patterns. And that's all math really is. When you break it down, it's just patterns found in nature. And then once human beings found these patterns, they wrote them down and they applied all kinds of other things, ideas to them, and made what is called the branch of mathematics that we know that it is now. So patterns begin with studying the stars and the earth and things like that, counting things, objects, items for domestic use. So sequences just deals with looking at how patterns are made. So let's get into it. There's our objective, our vocabulary. There's a lot of vocabulary here. What sequences look like. Okay, so let's look at our first example. Find the constant of difference in the next 4 terms in the sequence. So how do we attack a problem like this? And this is really good to get us thinking about algebra and really dealing with functions, how lines are made and graphs are made. So we can see that this thing is going up by 3. We started at 4 and we added 3, we added 3, and we added 3. So we know that this, whatever is going on, is adding by 3. So that is what we would call our constant of difference, is plus 3. And so the next 4 terms in the sequence will be 13 plus 3, will be 16, 19 plus 3, 22, and then 25. And so that's all we had to do for this problem. Find the constant of difference, which is 3, and then use the constant of difference to find the next 4 terms in the sequence. So let's look at example 2. Find the next 4 terms in the sequence. So we don't need the constant of difference. So we go from 3 to 12 to 48 to 192. I don't know what to do here. So if I divide 12 by 3, I get 4. If I divide 48 by 12, I get 4. And I bet you if I divided 192 by 48, I will get 4. So this is a multiply by 4 situation. All right, so find the next terms in the sequence. So if we multiply 192 times 4, we would get 768 times 4 is 3072 times 4 is 12,288 times 4 is 49,152. You know what? Let me erase this comma out of here so you don't get confused. This is not one number. These are 4 separate terms. So 768 times 4 is 3072 times 4 is 12,288. times 4 is 49,152. So example 3, find the missing term for the arithmetic sequence. So in an arithmetic sequence, we are adding and subtracting. In a geometric sequence, we're multiplying and or dividing. So what you're going to have to do is find the difference from 84.6 to 71.4 minus 71.4 gives us 13.3. So 71.4 minus 58.2, 84.6. What did I do? 13.2. 2, 13. So the change from here to here is 13.2. The change from here to here is 13.2. So they're telling us this is an arithmetic sequence. So this means we can add 13.2 to 84.6. And we get 97.8. So if we add 13.2 to 97.8, we should get 111. And we can see that's what we get. So the missing term is 97.8. Okay, let's look at example 4. Okay, so the missing term for this geometric sequence. And all a geometric sequence means is that you're multiplying and dividing in between the terms. So that's the big difference between arithmetic and geometric. So let's see what we have. To go from 1 to 1/8, well, we had to multiply by 1 over 8. And if we multiply by 1 over 8, we get 1 over 64. So our constant of difference must be 1/8. So 512 times 1 over 8 will give us 64. Times 1 over 8 will give us 8. Times 1 over 8 will give us 1. Okay, so we found all the terms in the sequence. Times 1 over 8 will give us 1 over 8. So the missing term in the sequence is 8. So that's what was missing. So those were our examples. Please work on the practice problems, and I will see you at the end of the video for a review. Okay, describe each sequence as arithmetic, geometric, or neither, then find the seventh term, if it is geometric or arithmetic. So, let's see. To go from negative 10 to 3, you have to add 7. And if you add 7, and if you add 7. So we're adding 7. So if we're adding or subtracting, it's arithmetic. So this is arithmetic. And then find the seventh term. 1, 2, 3, 4. So our first term is listed. Second term, third term, fourth term. So if we add 7, we get 18. If we add 7, we get 25, 5, 6, and in seventh term, by adding 7, we get 32. So 32 is our seventh term. And that's how we figure out what term we have, and that's how we figure out our numbers. So let's look at problem 2. Same thing. To go from negative 5, so I'm going to go backwards. So this is our first term, this is our second term, this is our third term, this is our fourth term. So watch how I go backwards. So I know that 5 times 5 is 25, but this is negative 5. So if I multiply by negative 5, I'll get the positive 25. If I multiply 25 by negative 5, I'll get negative 125. And so 125 times negative 5 will give me 625. So what am I doing? I'm dividing by 5 here. Or I'm multiplying by negative 1/5. Either or. And sometimes with problems, if you just work it backwards, it will make sense. So if I multiply 5 by negative 1/5, I get 1, which is my fifth term. If I multiply 1 by negative 1/5, I get negative 1/5, which is my sixth term. Then I multiply by negative 1/5, and I get 1 over 25, which is my seventh term. So look how this goes. It goes positive, negative, positive, negative, positive, negative, positive. So all things have to work out. And that is the answer to problem 2. Okay, so we have to look for the pattern here. And let's see what we have. We can go from 1 to negative 1.1 by adding. But here's the thing. This number here, I don't think we could get there by adding or subtracting. So let me try multiplying 1 times negative 1.1. And I know when I multiply by 1, I get the same number. Okay, so that makes that work. But what if I multiply by negative 1.1 again? I get positive 1.21. If I multiply by negative 1.1 again, I get negative 1.331. Look at that. So our missing term was 1.21. And how did I figure that out? I multiplied by negative 1.1. The first and second terms have a relationship. And once you figure out what that relationship is, you can solve any problem, any of these sequence problems. I wish I would have been given a second term, and it would have been much easier to find a third term. So this required some guesswork. Okay, so let's look at problem 4. Let me rewrite these fractions. So 256 over 27. And then we got 64 over 9, and then we get 16 over 3. And then we don't know what's here, and we know that 3 is here. So to go to 9, you have to divide by 3. So how do we get from 256 to 64? So let's divide 256 divided by 64 gives us 4. So if we divide by 4 over 3. 64 divided by 4 is 16. 9 divided by 3 is 3. Okay, so it looks like we got a pattern. But this is what we're going to do. We're going to do 256 over 27. And we know that when we divide fractions, we have to multiply by the inverse. So we're going to multiply by 3/4. And so we know that we factor out, and that becomes 9. And this becomes 1. And that becomes 64. And so that's how we get 64 over 9. Then we multiply by 3 over 4 again, cross factoring. 3, and then 4 goes into 64 16 times. That gives us 16 over 3. Times it by 3 over 4. They cancel out. 16 divided by 4 is 4. Times it by 3 over 4. The 4's cancel out. We get 3. Okay, so it works. So the missing term is 4. That was the missing term here, was 4. We multiplied by 3/4, or we divided by 4/3. So these series of lessons may or may not be taught. A lot of curriculums just don't have the time to go over this unless you start your algebra early. And a lot of teachers will not start arithmetic and geometric sequences together. You'll start looking at shapes, and they will be coming in an upcoming video. So here's arithmetic and geometric sequences. So the big difference is arithmetic series, add and subtract in between each term. Geometric sequences, multiply and divide in between each term. And we know that addition and subtraction are the same thing. They're just adding the inverse of a number. And multiplication and division are the same thing. Division is just the multiplication of the inverse. The multiplication inverse, or the multiplicative inverse, is any number upside down. So, for example, if you have 9, you would flip it upside down and become 1 over 9. If you're multiplying by 1/3, you would flip that upside down and it would become 3. So for the additive inverse, it's the opposite of a number. So if you're adding by 3, the additive inverse is -3. If you're subtracting by 1, the additive inverse is +1. So that goes back to properties of numbers, and I put my properties of numbers videos with my numbers and operations. So you had to go back into numbers and operations playlist and find properties of numbers. You may find a properties of numbers early in algebraic concepts. It might be one of the first 5 or 10 lessons. So thank you for watching this video. Series and sequences come up in 6 or 7 videos. So please watch all of these videos in together to get a full understanding of how sequences and series work. And this will be the prelude for moving us into functions.